shortest distance of a point from a line. And in the first method, our line is r equals to a plus lambda b. Remember, this is the vector equation of the line, and this is a point on the line, and we call b the direction of the line. So we've been using the assumption that this guy here is the position vector of a point A on the line. So the first method, if we have this as our line, we have r equals to a plus lambda b, and then we have the point P here, the point P. Then on this line, we know a point A. We know that point A, of course, whose position vector is that one there. And so if I want to get this distance, the distance we are looking for, the shortest distance, is that perpendicular distance there. We could denote it as d. The first thing we will do, we will get this vector AP, that vector AP there. And since this is known and this is also given, then we can get the vector AP. Of course, it is OP minus OA. And then we get this other vector here. This is the direction of the line, so we could call that the vector B. And then we obtain the angle between those two vectors, that angle there. Actually, we don't even need the angle, so we use the dot product to get the angle theta. So one, we know that cos theta, theta is the angle between this vector AP and the vector B. So using the dot product, this is going to be the magnitude of AP, and then times the magnitude of the vector B, and it is going to be AP dot B, and then over magnitude of AP, and then dot B times magnitude of B. So after getting the cosine of theta, you can now too get sine theta. You get sine theta. There are many ways you can get sine theta. You can draw the triangle, use SOHCAHTOA, and get sine theta. We don't need the angle, we need the sine of theta. And then 3, now, to get the distance d, using your SOHCAHTOA, that means d is, it's going to be AP, magnitude of AP, and then times the sine of theta. That was one method. So from this right angle triangle, just put in a little trigonometry, and you'll know that that distance from here to there, given the hypotenuse, the angle theta, we can find the opposite using using that. Of course, there are these other things which go on there, but we don't need them. Just use this. You get the relation between this guy, the angle, and d, and then you have d. Then the other method you could do is, you could maybe first of all find the projection of the point P in the line. You could say, let Q, let me use a simple diagram. This is our line, this is the point P. And so we want to get that distance d. You're given P. What you do, first of all, find the projection of P in the line. That is the point at which the perpendicular dropped from the point P meets the line R equals to A plus lambda B. So we are going to try to find this point here. Now, of course, this point here lies on this line. So if, remember our A, if it has coordinates A1, B1, and then C1, then it means that our point Q should be A1 plus maybe lambda B1, where, of course, remember also we're taking our direction vector. This is A1, A2, A3, then B1, B2, B3. And so this should be A2 plus lambda B2, and then you could have A3 plus lambda B3. So one, you're going to use PQ dot, because this vector here, the vector PQ, must be perpendicular to the direction vector. It must be perpendicular to that vector B. So use PQ dot B equals to 0 to find the value of lambda at point Q. Point Q. Remember, we are saying Q is the projection of the point P in the line there, or it is the foot of the perpendicular dropped from the point P to the line. So we use PQ dot B because this vector is perpendicular to that one, the direction of the line. So find the value of lambda at point Q. Now once you know the value of lambda at point Q, remember these are known, then you have the point Q, and therefore our distance D. So you find PQ, since now you already have the point, by substituting in lambda, substituting in the value of lambda, and then 3, we will have our distance D being called the magnitude of PQ. So all those are possibilities you could use to find that. It is not very complicated. We could use an example. Example. Find the distance of the point. Find the distance of the point. A, which is 4, -3, 10 from the line. R equals to 1, 2, 3, and then plus lambda into 3, -1, 2. We want to find the distance of that point there from that beautiful line. Yeah, you could use some 3 seconds to copy that as I clear the space where we are going to have our working. So in our solution, let us first of all try to use method 1. You could use a sketch if you don't want to get very confused. We have our line, and then we have our point. You don't need to be very accurate. It is just a sketch. You don't know where each one is. You don't have a reference point here on the blackboard as the origin, so just sketch. And then now, having gotten that, we also have a point. Now I've used the A here. Let me change this so that we have our point A here, a point on the line, and this is the point, the position vector of the point on the line. So we have that as 1, 2, and then 3. And so we have the vector AP, which we are talking about. We have that vector AP there. And so what we are actually looking for is this distance here. But we are first of all going to have to find that angle there. So that's the vector AP, and then this is the vector B equals to the direction of the line. B is 3, -1, 2. 3, -1, 2. So we are first of all going to find cos theta. That's what we are going to find, and then we shall find sine theta, and then everything will be okay. Now we are going to use the dot product, so we shall get vector AP. The vector AP is OP minus OA. Vector AP is OP minus OA. That is end point position vector minus starting point position vector. So we shall have 4 minus 1, which is going to give us 3. And then we'll have -3 minus 2, which is negative 5, and then we will have 10 minus 3, which is 7. So that's the vector AP, and we shall also need the magnitude of AP, which is just going to be root of 3 squared plus negative 5 squared, and then plus 7 squared. So here we have 25 plus 49. What does this give us? We have 14, carry 1, 4, 5, 6, 7. So in this 74, we have to add 9. When you add 9, this is 31, so that is 83. So that is the magnitude of AP, root of 83. Then we have the direction of the line. That is the vector B, and this is given by 3, negative 1, 2. And then we shall also need its magnitude. Magnitude of B is going to be root of 3 squared plus negative 1 squared plus 2 squared. And so we have 9 plus 4, which is 13. And then 13 plus 1 is 14. So that is the magnitude of B. Now we shall also need the dot product of those two vectors there. I need the dot product of those two vectors. And so we shall say AP dot B is going to be equal to, we have 3 negative 5, 7 dot 3 negative 1, 2, and this is going to be 9 plus 5, which is 14, and then 14 plus 14, that is 28. So the dot product there is 28. Now, having done that, we are now going to find cos of theta. So we shall say cos of theta is going to be 28 over, that is the dot product, AP. I don't want you to get confused. AP dot B over magnitude of AP times magnitude of B, which is equal to 28. 28 over root 83, root of 83 times root 14. And we could use the services of a calculator or round off. These are not very, very beautiful results, so that I find theta. So which means that theta is going to be the cos inverse of 28 root 28 root of 83 times 14, root of 83 times 14, and this should be equal to 28 divided by root of 83 times 14. This is 0.82, 8214. And so theta is going to be equal to, the cos inverse of that is 34.7748. Okay, so from there, if this is our distance D, we can name it D. So we will say D is equal to magnitude of AP, magnitude of AP times the sine of theta, which is going to be equal to root 83, and then times the sine of that angle there. Shift sine, no, this is just sine So sine of theta, this is going to be 0.5703, 0.5705, 570304 if you round off. So times root of 83, this should give you something like 5.19661 units. So that is the one method you could use. Please copy very fast, or you can even scan using your hard disk, and then we try to look at the other possible method. Okay. So the other method, we shall let Q to be the projection of the point P in that line there. That's what we are going to do. We are going to let Q to be the projection. So here we shall, the second method, we don't directly use a given point on the line. Rather, we shall let Q to be the point. Now, if Q lies on this line, then it satisfies that. That means the x-coordinate of Q must be in the form 1 plus 3 lambda. 1 plus 3 lambda. The y-coordinate must be in the form 2 minus lambda. 2 minus lambda. And then the z-coordinate must be in the form 3 plus 2 lambda. 3 plus 2 lambda. And so we need to find the value of lambda at Q. We said Q is the projection of the point P in the line. And we are still going to use this information, the direction of the line, which is the vector 3, -1, 2. And so, to find the value of lambda at that point there, we are going to use PQ dot B equals to 0. These two vectors are perpendicular. PQ, the vector PQ, or we could, whatever, even if we use QP. Okay, PQ and then B, they are perpendicular. So we shall say PQ dot B is equal to 0. But the vector PQ, we shall have this minus that. So the vector PQ, we have 1 plus 3 lambda minus 4 is just 3 lambda minus 3. And then 2 minus lambda minus 3 is just 5 minus lambda. And then 3 plus 2 lambda minus 10 is just is -7. -7 plus 2 lambda. And then dot. You have to be sometimes very careful with these figures. You calculate things very, very well. Because when you make a miscalculation, you will not get the correct answers. However, what is most important is, have you picked the general concept at A level? We are interested in you grasping the concept, understand what is going on. That's the most important thing. Once you know that, then you can now focus on the calculations. So when I make a small mistake somewhere, do not be alarmed. Pick the general concept. That is the most important thing at the moment. Then when you sit alone and as you're going through and then you find somewhere or subtracting something and it is not tallying, you correct it. You correct it. So B, we have 3, -1, 2. This is going to be equal to 0. It is going to be equal to 0. So I hope everything is clean. 1 minus 4 is -3, 2 minus 3 is 5, and 2 minus -3, and then 3 minus 10 is -7. I think everything is okay. So we will have 3 times this gives us 9 lambda minus 9, and then -1 times that is -5 plus lambda, and then 2 times that is -14 plus 4 lambda is equal to 0. And so we have what is our lambda going to be equal to at the point Q? We have the lambdas, we have 4 plus 1, that is 5, and then 5 plus 9. 5 plus 9 is 14, so we shall have 14. And then we have negative 9, negative 5, that's negative 14. Negative 14 and negative 14. Negative 14 and negative 14, that's negative 28. It goes the other side. So we shall have lambda as 2. We shall have the value of lambda as 2. And so now we could find a vector PQ. This means that the vector PQ is given by, now, the vector PQ, we put in 2. This is the vector PQ. So you put in 2 here. We shall have 6 minus 3. 6 minus 3 is 3. And then 5 minus 2 is 3. And then negative 7 plus 6 is 1. So we have the vector PQ. Now we know that D, therefore, D is equal to the magnitude of PQ. And this is going to be the root of 3 squared plus 3 squared plus 1, which is equal to root 19. Root 19, oh, this is 9 plus 9, that is 18 plus 1 is 19. And I'm saying things are not agreeing. Again, I said there must be some small mistake in some subtraction and all that kind of thing. However, that is the concept. If you were seated near here, you would tell me that, hey, teacher, you did subtract this very well. It is supposed to be this. Yeah, but that is the concept. That is the concept. You should get the same values. There must be a very small mistake somewhere. But that is how you would deal with those things. So when you're seated in your sitting room, try to go over and see where did the teacher subtract wrongly. What is most important is pick the concept. Pick the concept. Pick the flow and understand how the things move. So you will try to check the two methods. In this one, I don't see any problem. So the small mistake must have been the first method. That is where it should have been. So be a good student, sit down, and you try to go through and see. You try to go through and see. Now, part G, you want to see how to find the distance between two parallel lines. Distance between two parallel lines. Distance between two parallel lines. So how do we find the distance between two parallel lines? Oh, first of all, if you want to find a distance between two lines, they must be parallel. And so how do we know that two lines are parallel? So the lines R1 equal to A, or 1 plus lambda B1, and R2 and R equals to A2 plus lambda B2 are parallel. If these two vectors are parallel. Lambda B1 is equal, oh, you could say B1 is equal to B2, but the more general thing is that B1 and B2 are parallel. The moment their directions are parallel, then the lines are what? And the lines are parallel. And so how do we find the distance, or what we call the separation between the two lines? So the task is to find the distance. Sometimes we can call it the separation between the lines R equals to A1 plus lambda B we don't use lambda. This should be a different parameter. Plus lambda b2 and r equals to a2 plus mu. This should be the same vector since we are saying they are parallel. We are saying they are parallel. So how do we find that distance? Now, it is important that you try to use a sketch. Let us have the two lines there. So if I want to get the distance between those two lines there, it is the shortest distance. We shall need, that should be the distance, Let's call it D. So how do we get D? The best way of getting D, pick a point, maybe A on the first line, a point A on the first line, and then find its projection Q in the other line, and then you'll get D as the magnitude of, let's call this L1, where L1 is the line R equals to A1 plus lambda B. And then let's call this L2, where L2 is R equals to A2 plus mu B. Since they are parallel, that's why we are giving them the same direction vectors. So what we do, we are saying the method is one, find, let A be a point on the line. This one is very easy to use, to get. In the first line, you could take this very point here. You could take that very point there. So we could say, let OA equals to A1. So let that vector be the one that. And so what we are going to do, to then find Q, find point Q, the projection of point A on line L2. So we are saying come to the first line, pick a point on the first line. We could pick this one whose position vector is already given. That is the point A, because for it is always given if we are given the equation of the line. So you choose that one. That is when lambda is 0. So you have that. It's a point on the line there. Then the next thing is you're going to find its projection in the second line, the point Q. And then now, of course, every other thing will be easy. So the separation D, will be given by magnitude of the vector AQ. Of course, remember we saw how you find the projection of the point in the line. You write it generally, and then you find the value of mu at that point using AQ dot B. AQ dot B is equal to 0. AQ dot B is equal to 0. So that is not very complicated. Let us clarify it more, perhaps with an example. So I shall say example. Determine the distance between the parallel lines. Determine the distance. When they mean distance, they are meaning the shortest distance between the parallel lines. The distance between the parallel lines. The first line is R equals to 0,3, and then plus lambda to 1,2, and the line R equals to 11, negative 12, 9, and then plus mu into 212. So obviously the direction vectors are the same, so the lines are parallel. The lines are parallel. Always train yourself to try using a sketch so that you don't get confused, so that you don't confuse yourself. It's important you try to sketch things and see them. So let's call this L1, where L1 is the line which was given first, and let's call this one L2. L2 is the line given second. I hope you don't get confused. Now we will need a point on the line, so we shall pick the point A, but the point A on L1, we could take this one here, whose position vector is already given. That's the point 2, 0, 3. And then now all we need is its projection Q, in the second line. Its projection Q. But since Q is lying on the second line, it must be of the general form 11 plus 2 mu, 11 plus 2 mu, and then negative 12 plus mu, negative 12 plus mu, and then 9 plus 2 mu, 9 plus 2 mu. So that is how it should look generally. So all we need now to find is the value of mu at point Q, and we will be okay. So this is the direction vector of the line B. And so the separation we are finding is this one here. Let's call it D. Now, so we shall use AQ dot B to find what we need. So we shall say AQ dot B should be equal to 0, because this guy, the vector parallel to this, and that guy, they are perpendicular. Now AQ, end point position minus starting point position. So AQ, we have 11 minus 2, so that is going to be 9 plus 2 mu. 9 plus 2 mu. Then we have negative 12 minus 0, so we have negative 12 plus mu. Negative 12 plus mu. And then we have 9 minus 3, that is 6, so we have 6 plus 2 mu. 6 plus 2 mu. And then we are dotting it with B. B is the vector 2, 1, 2. 2, 1, 2, and this should give us 0. So having obtained that, again I told you it's very possible to make small mistakes in the calculations there. What is very important now is you to grasp the concept. Pick the concept, then you sit down when you are alone and you begin working out these things. It's possible to make omission errors, miscalculations, and all that kind of thing. But you are not allowed to do that, because you have all the time at this moment. So we are going to have 18 plus 4 mu. This is going to give us 18 plus 4 mu, and then minus 12 plus mu, and then plus 12 plus 4 mu, and this as 4, 5 plus 4, that is 9. And then I have this and that going, so I remain with 18, but 18 over 9 is 2. Now that I have mu, but I didn't even need the point Q, I needed mu at Q. What I need is the vector AQ. So this implies that the vector AQ is going to be given by just putting the value of mu. So I have 9 plus 4. 9 plus 4, that is something like 13. 12 plus 2, that is negative 10. 6 plus 4, that is 10. Hope there are no mistakes there. Oh, this should be negative 2. This is negative 2. When this goes the other side, it's negative 2. Mistakes. You have all the time to expand this, make the other thing the subject, and all that kind of thing. Okay, so now 9 minus 4 is 5. And then negative 12 minus 2 is negative 14. And then 6 minus 4 is 2. 6 minus 4 is 2. If you are not allowed to make mistakes, yeah, you have to recheck your work, and so on and so forth. So D is now going to be equal to magnitude of AQ, and this is going to be equal to root of 5 squared plus negative 14 squared, and then plus 2 squared. So I have 4 plus 25, that's 4 plus 25, 69 plus 196, something like 225. So root of 225, that is 15. So that should be the separation between the two what? Between the two lines. You can use some 2 seconds to copy that. You can use some 2 seconds to copy that. Those who have a photographic memory, you can just look at it and you put everything on the hard disk. And that is possible because you are still young. Your brain is at its best. You don't have a lot of things to confuse you right now. If you have a lot of things which are confusing you at that age, you better get rid of them very fast. At that age, you should have a photographic memory. You look at something and it sticks on your mind. Okay, we want to look at another concept to do with distance. Another concept to do with distance. Another concept to do with distance. That is H. Distance between two skew lines. Distance between two skew lines. So what are skew lines? Remember we said in dimension 3 it's possible to have lines which are not parallel, but when they don't meet. In dimension 2 it is impossible. In dimension 3 it is very, very possible. And lines which are not parallel and don't meet, we call them to be skew lines. So skew lines, what are these skew lines? These are lines which are not parallel. And do not intersect. And do not intersect. So how can you tell that two lines are not parallel, are skew lines? You first have to check whether they are parallel. We have seen how to check. And then you check whether they do intersect, whether they have a common intersection point, and we saw that. If those two conditions are not satisfied, they are not parallel, they don't intersect, then they qualify to be called skew lines. So the task is to find the distance, the shortest distance. Sometimes when we say distance, we mean the shortest distance. So to find the distance between the skew lines, distance between the skew lines, L1 and L2, L1 and L2, between the skew lines L1, whereby L1 is R equals to A1 plus lambda B1, and L2, we shall have it as R equals to A2 plus mu B2. Let those be the skew lines. So how do we find the distance between the skew lines? I'm going to draw something in 3 dimensions. Hope I remember my perspective from fine art. Let's have that as the first line. Let's call that one L1. Then there is going to be the other one. It's not parallel, maybe something like, boy, no. Let me first draw something like this. Yeah, skew lines are not easy to draw, especially when you're drawing some three-dimensional thing on a two-dimensional platform. And then maybe you could also have that other line like that. Now those lines, someone, to be careful, let me do this so that I indicate that this is perpendicular to this and that this is perpendicular to this. Maybe that makes it very clear. Still not very clear. Let me try to make it very clear so that you understand what is going on. Now this line is lying in some plane, so let us assume this is the image. Let us assume that is the image of this line here in the plane containing this line, but that plane is parallel to that line. So now things are a little bit clear, I hope. Yeah, I hope. They should be a little bit clear by now. If they are not very clear, just give yourself a little time. You are far brighter than you think. All you need is a little time. And so, we shall have this point Q. The point Q is a line in L2. We shall pick a general point in L2, and then this is L1. Now these points must be in such a way that if you had a translation of this line into the plane containing this guy but parallel to this line, then the point Q should be the point where this guy here would. So in other words, if this is a point A, let me call it P, then Q should be the projection of P onto Q. Now you notice that when lines are skew, it seems like not every point can be projected onto the other line when they are skew, because if a point was here, we couldn't, I don't know, we could project it there maybe. We could, but these are two unique points which satisfy some special property which we are going to look at. So let's call this point P, and since it is in the first line, it must be of a general form. Let's not write that. Let's not write that. So the method is, we are going to use one. You let A, I call it P. So let P be on L1. Let P be on L1 and Q be on L2 as shown. So you draw and you let P be that point there and Q be that point there. Okay. Then two, you'll use PQ. You see the vector PQ is perpendicular to the direction of this line, perpendicular to B2. And it is also perpendicular to B1. So use PQ dot B1 equals to 0 and PQ dot B2 equals to 0 to find the value of lambda at P, find the value of lambda at P and the value of mu at Q. So once you have those two things, then D, the separation D, this one here, then the separation D is going to be given by magnitude of PQ. So as we wind up, let me leave you with a question you're going to try in your free time. So question, find the shortest distance between the skew lines. I'll be very glad if you send me your solution via that mail. Between the skew lines, I'll be very glad if you send me your solution to look at it via the mail I gave.